All right, so what does this term implicit form mean? Okay. So if a function f is defined by an equation that involves x and y, but it's not immediately clear how to get y equals blah, 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 we say it's implicit. Okay. So we'll see some examples. Okay. So if you can get y equals stuff involving x, that's called an explicit form. If you have an equation where y hasn't been solved for, that's an implicit form. Sometimes, and in all of the examples they've given, it can be done. An implicit form can be made into an explicit form by solving for y. So in this first line, if you solve 2x plus y equals 4, if you want to solve for y, all you have to do is move the 2x over, and you get negative 2x plus 4. If I want to solve this for y, I would just move the y over here, and I'd move the 7 over there, and you'd get x squared minus 7. To solve this for y, just divide by x, and you get y as 5 over x. So in this example, it's possible to solve explicitly for y. Just remember, we've been stressing this as we went through videos, each input can have exactly one output, but it's possible for an output to come from more than one input. That's fine. The symbolic language that we use is f of x for the function f. X is called the independent variable. Y is called the dependent variable. Okay. What about a difference quotient? This is a particular thing that's leading us up towards calculus. If you have a function f and you compute the following, f of x plus h minus f of x all over h, this is called the difference quotient. So for example, can you find the difference quotient for f of x equals x squared minus 1? Remember, what you want to compute is f of x plus h minus f of x all over h. So pause here and try to do that computation. Okay, so can you compute this difference quotient? So f of x plus h minus f of x over h. F of x is x squared minus 1, so I have x plus h squared minus 1. Then I subtract x squared minus 1, and again, parentheses here are your friends because you have this minus that's part of the difference quotient. So whatever your f of x is, use parentheses or you're going to make mistakes. Okay. If I expand that x plus h squared and I correctly distribute this minus 1, we end up with the following. Some stuff cancels out, namely the x squareds and the 1. I get 2xh plus h squared over h. Notice that numerator you can factor an h out of, leaving behind 2x plus h, and now you can cancel those h's. Fancy. Leaving behind just 2x plus h. Okay. Can you find the difference quotient for something a little more complicated? Again, I'm going to pause here. Try to do what's the difference quotient. Remember, it is f of x plus h minus f of x over h. So I'm going to pause. Try to simplify it down as much as you can. Okay. 1 over x plus h, notice that here, x plus h is entirely in the denominator. Okay. I do not get 1 over x plus h. F of x plus h is not 1 over x plus h. No, 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 no. It's 1 over x plus h, which is not the same thing as 1 over x plus 1 over h. No, 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 no. Fractions don't work like that. It's just 1 over x plus h. Then I subtract f of x, which is 1 over x, and I divide the whole thing by h. Now, how do I take the difference of two fractions? I need to find a common denominator. So the common denominator of these two fractions is just x times x plus h. Now, if I want to give them the same denominator, this first term already has the x plus h, so x over x, and the second one will be x plus h over x. If I were going to simplify this, notice these x's would cancel, leaving behind a 1 over x plus h. These x plus h's would cancel, leaving behind a 1 over x. So that's exactly what we have up here. X over x times x plus h minus x plus h over x times x plus h. And now that they have the same denominator, we can simplify them as this. And that's exactly what the book has done to get that. Okay, but it is all still over h. That's still here. Now if I simplify this, okay, I have one fraction over something else, so I can just take this denominator and make one big compound denominator out of it, and the numerator is x minus h once you do this distribution correctly. Okay, I'm going to remove all of my pen marks. They've gotten a little busy. But now notice the x's cancel, and now I can cancel that h, leaving behind -1 over x times x plus h. Okay, how about 2 times root x? F of x plus h, and I want to stress, okay, the square root of x plus h is not root x plus root h. It just isn't. That's not how it works. Don't do that. Okay. Unfortunately, we have nothing to do but work with this numerator as it stands. But, okay, what can we do? We're going to multiply. So notice this here is exactly what we have in the previous step, and I'm multiplying by something really ugly looking, but it's the same numerator and same denominator. So what have I really multiplied by? I've multiplied by 1. You're allowed to multiply by 1. Now, why on earth would I multiply by this? So the numerator has one square root minus another, and I'm multiplying by the same thing plus the same thing. Okay. This is what's called an algebraic conjugate. It's going to simplify the numerator a lot, at the expense of making the denominator a little worse. Okay. Because notice what I really have up in this numerator. I'm going to clear out my pen marks so that I can write some stuff. What I have up in the numerator is something minus something else times the same thing plus that something else. So if I call this thing A and I call this thing B, I have A minus B times A plus B. But that multiplies as A squared minus B squared. It's the difference of two squares factoring, which is why in the next line we have A squared minus B squared. And this is particularly nice because then the square roots up there can be canceled out. 2 squared times x plus h, 4x plus h. 2 squared times root x squared, which is 4x, up in the numerator. Okay, now the denominator still has all this stuff going on. It is what it is. Whoops, wrong button. Once I distribute out this numerator, however, the 4x minus 4x cancels, leaving behind 4h, and now those h's cancel again. Okay. So I'll stop this one here before moving on to how to find the domain. When you're doing difference quotients, all the examples we had, there was an h that canceled at the end, and in general, you're hoping that happens. It's not flat out guaranteed, but 9 times out of 10, and in this course, and in any sort of lower level, like Calc 1, Calc 2, by lower level, I just mean not like senior level classes for math majors. In any examples we give you, they would cancel out. So you're expecting that h to cancel out in your difference quotient.